So, we want to talk about different operations, things that we can do with our functions. And if you guys go home and read your textbooks, like I'm sure you do, they have all these long, elaborate rules, but it's really pretty basic. Okay, if I give you two functions, and I ask you to find operations, like f plus g of 0. You guys let me let you write down those functions? If it were me, I would just write down like f of x equals 3x minus 4, g of x equals 2x squared minus 1. All this means is you put a 0 into f, a 0 into g, and add your answers together. Right? So if I put 0 into f, remember that's just replacing your x, so 3 times 0 minus 4, which gives me negative 4. If I put 0 into g, 2 times 0 squared minus 1, so negative 4 plus negative 1. It's negative 5. So if I ask for f minus g of 4, we're going to plug a 4 into f, plug a 4 into g, and subtract those answers. So if I put a 4 into f, three times 4 is 12, minus 4. I put a 4 into g, 2 times 4 squared minus 1. So 16 times 2 is 32, minus 1 is 31, so 8 minus 31. I want you guys to try those two. So if you put a negative 2 into f, 3 times negative 2 minus 4, so negative 6 minus 4 is negative 10, times, if you put a negative 2 into g, 2 times negative 2 squared minus 1, so that's 4 times 2 is 8, minus 1 is 7, and negative 10 times 7 gives us negative 70. Second one, if I put a 3 into f, so 3 times 3 minus 4 gives me 9 minus 4, or 5. If I put 3 into g, so 2 times 3 squared minus 1, so 18 minus 1 is 17, 5 over 17. So we should be able to plug in a value for x and evaluate these functions. Is that okay with everyone? All right. Make sure you don't have anything else out right now. You can put that away. All right, let's talk about domains. When you add, subtract, or multiply, we have to find the overlap of the original domains. So if I'm going to add two functions and get my domain, I have to take whatever numbers work for the two original ones and put them together. Dividing is different because we also know if you divide, what can't you divide by? 0. So division is the same, except the denominator cannot be 0. So adding, subtracting, multiplying will all have the same domain. We just take any number that works for both of the original ones, it's in the domain when you add, subtract, and multiply. Division starts there, but then we have to look if there's anything that makes the bottom 0 and remove that one. So let's practice a couple of these. Let's say f of x is the square root of 4x minus 1. G of x is x for x minus 3. I want to find and give the domain for the following. If I say f minus g of x. Okay, that's a little bit different because did I give you a number to plug in? No. So this just means you're going to take f of x and subtract g of x. What is f of x? Minus g of x. X over x minus 3. Do I have any like terms I can combine or anything? No. So as far as subtracting them, that's my answer. For my domain, I have to think about each of these functions individually. If you have the square root of 4x minus 1, what do we know about the domain of a square root? Anything under the radical has to be positive, right? So that means 4x minus 1 has to be greater than or equal to 0. So that means I can only plug in things greater than or equal to 1/4. This one is a fraction. If you have a fraction, what do we know? The bottom of the fraction, the denominator can't be 0. So x can't be 3. All right, so my domain, when I subtract them, I have to put both of these together. So greater than or equal to 1/4, but not 3. If you want, you could even think about a number line if that helps you. Greater than or equal to 1/4 looks like this. But I said it can't be 3, so we have to take out the 3. So my domain would be bracket 1/4 to 3 with a parenthesis because it can't equal 3, union 3 to infinity. Only those numbers make both of the original functions true. Now, if I didn't have radicals, so if I just had like a polynomial that was just x plus 3, what's the domain of that? Negative infinity, positive infinity. So if you don't have fractions or square roots, then your domain is everything. But we did have to consider that here. What if I asked for f times g of x? So that just means we have to take f of x times g of x. So the square root of 4x minus 1 times x over x minus 3. What you could really do there is put this as a single fraction, x times the square root of 4x minus 1 over x minus 3. Can't really do anything else. But what would the domain of this be? Close. It's going to be, we still can't put in like a 0 because we get a negative under that square root. When you add, subtract, and multiply, your domains are the same. So it's going to be the same as the domain when we subtract it. So it's just 1/4 to 3 just putting their two individual domains together. I want to put a problem up here for you guys. If I said f of x is 8 minus 4x, g of x is 3x plus 1. We're going to define f plus g of x and its domain. And we're also going to do f divided by g of x and its domain. F plus g, we're just adding 8 minus 4x plus our 3x plus 1. Can we combine some like terms there? So we would get 9 minus x, or negative x plus 9. The domains. If I look at f, did it have any fractions or radicals? So what's the domain of that? Negative infinity to infinity. What about g? So when you add, subtract, or multiply, the domain is all the same. So both of those, you could plug in any number. I can still plug in any number at the end. For f divided by g, so f is 8 minus 4x, g is 3x plus 1. With these fractions, I'm not expecting you to do long division or anything. I just want it written as a fraction. Okay, does anything cancel out here? No, so they're not all divisible by 2 or anything. That's all I'm looking for. The domain, when you divide, it's the same as when you add, subtract, or multiply, so it's the same as these, except what can't happen if we're dividing? So I know 3x plus 1 cannot be 0. So x cannot be negative 1/3. So how do we write that? Any questions about those? Bracket means equal to, and we're saying it can't equal the negative 1/3. Good question. Any others? I want to make sure you can evaluate functions from a graph as well. So, for each of these, we're going to do f plus g of 1 and f divided by g of negative 2. So if I want f plus g of 1, that means f of 1 plus g of 1. Remember, we practiced this when we first talked about functions. We practiced evaluating them from a graph. This is saying if x is 1, what's the y value? So f here is this upside down parabola. When the x is 1, what's the y value on that graph? Okay, so then, we've got 3 for that one. G of 1. So when x is 1, what's the y value of g? So 3 plus 1 gives me 4. If I ask for f divided by g of negative 2, so we have to do f of negative 2 over g of negative 2. On function f, so my parabola, when the x is negative 2, what's my y? 0. On function g, when the x is negative 2, what's the y? And 0 divided by 2? So do we remember evaluating our functions from graphs? So we could work with those. We can also do it from a table. F plus g of 1. What is f of 1? I'm saying my x is 1, so careful, positive 1. When the x is positive 1, what's the y value of f? 1. Plus, what's the y value of g? 1 plus 6 gives me 7. If I ask for f divided by g of -2. When the x is -2, what's the y value of f? -5. G? Can you do -5 divided by 0? So that one is a no solution. So we should be able to evaluate functions from their graphs and add, subtract, multiply, or divide, or from a table. Any questions about that? So 2 more things that I want to talk about for today. The first one, this goes along with evaluating functions. Sometimes you might be asked to do a more complex expression. This actually has a name to it. It's called a difference quotient. It shows up a lot in calculus, but sometimes this is even an ACT question because it's really just evaluating functions. So you might be asked to find this type of expression. For us, if I'm going to give you these questions, I would make this like a 3-part question and I would break it into pieces for you. So my function, can I change this actually just for our first example? I'm going to do this one for B. I'm going to do a nicer one to start with. Let's do, here, for our first one, let's do 3x plus 1. Sorry, changed my mind. Okay, so the first step you have to do, f of x plus h. What does that mean? If I said f of 5, what would you do? You put a 5 in for x. So when I say f of x plus h, I'm replacing my x with x plus h. Okay, we can distribute, but I don't have any like terms, so that's as far as my answer goes. The second part, I would tell you find f of x plus h minus f of x. What is f of x plus h? Yeah, it's the answer we just got out. Minus, what is f of x? What's my original? 3x plus 1. What would I do with my negative? Then 3x and negative 3x cancel. 1 and negative 1 cancel. And we just get 3h. Third step. F of x plus h minus f of x divided by h. That's saying f of x plus h minus f of x. What is that? It's the answer we just got. So I'm saying take the answer you just got and divide it by h. What do we get? 3. So if you're just looking at the final expression, it looks pretty complicated. But if we take it one step at a time, we're just evaluating one thing and using that answer on the next step. Let's try one more of this. Hello? Okay, thank you. Wyatt, you're leaving. Let me know if you need help. Okay. What if I said f of x equals 2x squared? So the first thing I would ask you to find is f of x plus h. So what does that mean? Replace x with x plus h. How would you square that? FOIL it. So this means x plus h times x plus h. That would give me x squared plus xh and plus xh would be 2xh plus h squared. Then what would we do? Distribute the 2. So we get 2x squared plus 4xh plus 2h squared. On any of these problems, the first step is the hardest. Okay, that's going to be the ugliest answer. Every step beyond this, our answer should get a little bit nicer. So we had to FOIL the x plus h, then multiply our 2 through. The second piece says find f of x plus h minus f of x. But what is f of x plus h? The answer we just got. Minus, what is f of x? What happens? 2x squareds cancel, and we get negative 4xh plus 2h squared. That's a plus, isn't it? Alright, so then our third step, we have f of x plus h minus f of x all divided by h. So what do we do? The answer we got, divided by h, if I take an h out of everything, we get 4x plus 2h. So if I'm giving you one of these, I will always break it down into an ABC question. I'm just checking, can you evaluate these functions? Don't get scared because it looks ugly and there's a lot of variables. Each step should get a little bit nicer. Any questions on that? The last slide I want to go over today. You have seen it before. You've talked about function compositions. So if I told you f of x is 2x squared minus 3, g of x is 4x. If I ask for f composed with g of 1. Remember that little bog and golf when we were talking about these? Another way it might be written is f parenthesis g parenthesis 1. And on these, you're doing a series of operations. You start on the inside. G of 1. What does that tell me to do? I'm going to go to function g and plug in a 1 for my x. So 4 times 1 is 4. I get that answer, so my g of 1 turned into a 4. So now f of 4, what does that mean? Go to function f, plug in a 4. So you work the inside one, get your answer, plug that into the outside. So we get 16 times 2 is 32, minus 3 is 29. Does order matter with compositions? Yes. Let's double check in case we forgot. This one says you're doing g of f of 1. So what do you do first? The inside. So I'm going to start by putting a 1 into function f. Okay, so that would be 2 minus 3, which is negative 1. I'm putting that into g. That would be 4 times negative 1, or negative 4. So, order makes a big difference on this. You always start on the inside, work your way out. Can you do, what if I said f composed with f of 2? Can you compose a function with itself? Yeah, no reason you can't. You start on the inside. F of 2. I put a 2 into f. Get 4 times 2 is 8, so 8 minus 3 is 5. And then we have f of 5. So I'm going to plug 5 back into f. So you can compose with the same function over and over again. Any questions about this stuff? I'm not totally done with the section, but I do have a handout that is just over the stuff we did today. So this handout is